Hello students, I hope you all are doing well at home and staying safe and healthy. I also expect that you all are revising the chapter of biomolecules and continuously reading the text. We have already covered up the introductory part of it. As well, we have discussed about the carbohydrates and its classification. So children, coming on to the next part of biomolecules, we have monosaccharide group. As we have discussed earlier, they cannot be further hydrolyzed. These monosaccharides are present naturally in sweet fruits, ripe grapes and honey. And commercially they can be prepared by the following two methods. The very first method is from sucrose, that is your table sugar. When sucrose is boiled with a dilute acid, which is hydrochloric or sulfuric, in alcoholic solution, glucose and fructose are obtained in equal amounts. This can be chemically represented as sucrose as C12H22O11. When it is hydrolyzed in the presence of an acid, it produces glucose and fructose C6H12O6 with the same molecular formula in equal amounts. The second commercial method of preparation is from starch. Glucose is also obtained by the hydrolysis of starch by boiling it with the sulfuric acid at the temperature 393 Kelvin under the pressure of 2 to 3 atmosphere, which can be chemically represented as such. When it comes to the straight chain structure of glucose, it is very well exhibited here. It has 6 carbon atoms in a straight chain form, one aldehydic functional group having hydroxy groups. You can see to it last group represented as CH2OH. Children, it was not easy to confirm the structure of glucose. So with the efforts of many scientists and with the evidences, the following structure of glucose was confirmed. Let's proceed further. It is known as an aldohexose, which is also commercially known as dextrose. Aldohexose means having an aldehyde, hex means 6 carbon, OSE, that means it is a sugar. It was assigned structure on the basis of following evidences. Very first, with the help of mole concept, its molecular formula was designated as C6H12O6. Then chemically, when it was prolonged heated with HI, it forms an N-hexane, that is normal hexane. This structure confirms the presence of 6 carbon atoms in a straight chain form. This can be represented as such: glucose on heating with HI forming a straight chain compound of 6 carbon atoms. Further, it was treated with the mild oxidizing agent bromine water. On oxidation with bromine water, you can see the aldehydic group converts into carboxylic and it forms the product as gluconic acid. This confirms the presence of an aldehydic group in it. Moving on further, the next evidence was being found in the presence of hydroxylamine. When glucose is reacting with hydroxylamine, that is NH2OH, children, it forms an oxime. You can see in this equation, glucose aldehydic group is converted into an oxime, that is CH double bond NOH group. And this further, on treating the same glucose with HCN, it gives cyanohydrine. As you can see in the equation, glucose on treatment with hydrogen cyanide, the CHO groups convert into a cyanohydrine, carbon attached with OH group as well as with cyano group. So it forms the product glucose cyanohydrine. This is how, with the help of these two tests, we found that there is a presence of a carbonyl group in glucose. This was a further evidence. Coming on to the next, on acetylation. On treating with acetic anhydride, glucose converts into penta-acetyl glucose. That means all the 5 hydroxy group get substituted by the acetyl group. And this is how confirms the presence of 5 OH groups. Moving further, on oxidation with a strong oxidizing agent, that is nitric acid. You know it's HNO3. Glucose as well as gluconic acid, both of them on oxidation gives saccharic acid. This formation of saccharic acid confirms the presence of a primary alcoholic group. As you can see in the equation, the CHO group gets converted into COH, the CH2OH group also converts into COH. So it's a disaccharic acid named as saccharic acid, which is on treatment with the strong oxidizing agent. These were the evidences obtained for the open chain structure. But though we have obtained the structure, there are certain limitations which were found later on. The limitations are, very first, glucose doesn't give Schiff's reagent test, and it doesn't form hydrogen sulfide as an addition product with NaHSO3, that is sodium bisulfite. This is one of the major limitation. We have found that it has CHO group which reduces Tollens reagent as well as Fehling solution, but this Schiff's test is not successful. The second limitation arises in the form of the pentaacetate of glucose doesn't react with hydroxylamine. This indicates the absence of free CHO group. Further, one more limitation was that glucose is found to exist in two different crystalline forms, that is alpha and beta form. The alpha form has a melting point of 419 Kelvin, whereas beta has a melting point as 423 Kelvin. So children, concluding this session, we have already discussed about the glucose, how it's being prepared and its open chain structure with the evidences about its aldehyde group, 6 carbons in a chain, hydroxyl groups and the carbonyl group present in it. Further, in the coming session, we will be discussing about the limitations of this structure and how the cyclic structure was being proposed. Keep visiting our school website of St. Arnold's High Secondary School for further updates. Thank you.